Hello, my name is Mr. Bloch, but you may already know me as the definition of a limit guy. But today I'm going to be talking about definite integrals. So, to start off, when finding a definite integral, one is primarily finding the area under a curve that is between 2 points on the x-axis. Before this section, we learned how to approximate this area by using rectangles. We calculated this approximation using the right endpoint, the left endpoint, and the midpoint. Now I'm going to explain how to find the precise area using Riemann sums with the limit of n approaching infinity. Okay, so when finding an integral, we're finding an area in between b and a. You always want to remember to put b on top and a on the bottom. If not, we might be reading it from the wrong side, changing this into a negative. That's where a lot of people make mistakes. So the limit as n approaches infinity is going to be the sum of f of x times change in x. So before we were finding the sum of big rectangles to find the area, which were approximations. Now we're going to be finding pretty much an infinite number of rectangles. Alright, so something to learn before we get further in is summation formulas. These formulas will help us find out our Riemann sums. So, the first one is the summation of a constant is equal to the constant times n. Number 2, the summation of I is equal to n times n plus 1 all over 2. 3, summation of I squared is equal to n 2n squared plus 3n plus 1 all divided by 6. The fourth one, the summation of I cubed is equal to n squared times n plus 1 squared all over 4. Alright. Knowing these formulas will come in handy when calculating Riemann sums. So, what we're going to go into next is Riemann sums. And pretty much this is how you're going to find the area under the curve. So, Riemann sums have 6 steps. So the first one is to find the change in x, or the width, which is b minus a all over n. The second one we're trying to find ci, which is an expression for the endpoints. So we use ci is equal to a plus I times the change in x instead of using the left endpoint or the right endpoint because it is simpler, but primarily the same. The third is to find the function of ci. So right here we would have f of x, the integral of f of x. We would plug ci into that x, and we would go from there. So number 4 is to find the summation of f of ci. So after that, step 5, we're going to be multiplying the width, or the change in x, times that summation of f of I. Finally, to set this apart from what we did before, is we're trying to find the limit as n approaches infinity. So we're finding an infinite number of rectangles inside that shaded region, finding the area. Alright, so now that we know how to do this, I'm gonna give an example. It all might seem a bit complicated as of now, but I think after this example, it will be easier. It'll be easier. Another thing is that you're gonna have to memorize these 6 steps and those 4 summation formulas in order to get these correct on the test. All right. So let's see. So the example today is going to be an integral from 4 to 0 x cubed dx. dx is there just to show you what variable we're using, and as of now it's going to be x. So step number 1. We want to find the change in x. So the change in x is b minus a all over n, which is 4 minus 0 over n, which is 4 over n, 2. we're trying to find CI. CI is equal to a plus I change in x. So since a is 0, we can just multiply I times our change in x, which we found in step number 1, which is 4I over n. Now, for step 3, we want to plug in CI into the function. So the function is x cubed. So we want to plug in CI 4I n to the power of 3. Alright, so we get 64I cubed over n cubed. Number 4 is the summation. N I is equal to 1, 64I cubed over n cubed. We want to put 64 over n cubed, we can take that to the left of our summation, and it will look something like this. 64 n cubed summation of I cubed. You see, this is where it comes in handy, our summation formulas. If you were looking this on a test and you had no idea what our summation formulas were, you'd be totally lost, because you have no idea what I cubed is equal to. So, I cubed, what is it equal to? It's our 4th step in our summation formulas. So I cubed is equal to n squared n plus 1 squared over 4. So you want to multiply this by 64n cubed, but just in order to save some space, I'm going to erase this. But I think everything from 1 to 4 is pretty straightforward anyways. It starts getting more complicated as of now. So you want to multiply this 64n cubed. From here you can cross out some things. You can cross out n squared, take away the 3, that 4, put 16. And what number are we left with here? We're left with 16n plus 1 squared all over n. Erase that very quickly. Okay. From here, we want to multiply, we want to do the 5th step. We've just finished the 4th step. So the 5th step, what is it? It's to multiply times the change in x. The change in x, as we had before, was 4 over n, which is b minus a all over n. So this is equal to 64 n plus 1 squared all over n squared. So that was the 5th step. Now on to the 6th step. We want to find the limit n approaches infinity of this. So to simplify this a little bit, I'm going to put 64n squared plus 128n plus 64 all over n squared. This is equal to, I'm going to infinity, 64 plus 128 over n plus 64 over n squared. And as we know now, any number over an infinity is 0. So we plug in infinity there, we get 64 plus 0 plus 0. There's the magic number, 64. Alright, so now that we know how to do these, I just want to give a little something to look at when we're doing these. So when you're looking at integrals, you want to make it as simple as possible for yourself. You don't want to have to do this much work. So there's a couple things that you can look out for as of these two things. So you want to recognize that if you have an integral and both of these are the same number, you don't want to find this out the long way. You just want to be able to look at this and see that if you're not moving anywhere, if your limit is a and your other limit is a, same spot, you're not finding any area, it is equal to 0. So 2, if f is interchangeable on a and b, then you can have A, B. Notice how A is there and B is there. It's flipped. You can have this equal to that. That's negative. All right. So just looking at this, you want to make it as simple as possible. You don't want to always have to rely on that, but you will see these sometimes, and if you do, remember this. All right. Hope this video was helpful, and yeah, good luck on any tests that you have to take from here. Gabe is out.